Okay, problem number 1. 3 forces are applied to a beam as shown. So we have 80 pounds at point B, 75 pounds at point C downward, and 90 pounds at point D going upward. So replace the 3 forces by an equivalent force couple system at point C. So at point C. So let us try to replace this system by an equivalent force couple system at point C. Okay, so this is now the beam. So we have your point A, we have your point E, so we have at point C. So this is now your point C. So this one is your point B. This is your point D. So let us try to replace the original system by a force couple system at point C. So I is going to consider now that this is now the line of action of the resultant force. And this is the line of action of the resultant force. And we now have, so there is the resultant force, and we now have a couple also at point C. So I is going to assume that the couple at point C is a counterclockwise moment, and that is now your couple. Now, so from this figure, if you try to determine now the resultant, so the resultant in the x direction is now equal to summation of forces along the x axis or in the x direction. I'm going to consider to the right forces positive. Now, since all the forces are vertical, hence Rx is equal to 0. Is now equal to 0. Then we now have your Ry is equal to the summation of forces along the y or in the y direction, taking upward forces positive. So your Ry is now equal to, so we have upward, so that is positive 80, downward, so we have minus 75, upward, so positive 90. Then your Ry in here is equal to 95 pounds. We get a positive value, therefore the direction of Ry is going up. So this is going up. Therefore, since Rx is equal to 0, then the resultant is equal to Ry, and this is equal to 95 pounds going upward. So the resultant in here is now going upward, and this is equal to 95 pounds. Now, let us try to determine now the couple moment or the couple at point C, which is now your M. So the couple at point C, so the moment of the resultant about point C is equal to the summation of moment of all the forces about the same point, which is equal to C. I will going to take counterclockwise moment as positive. So the moment of the resultant about point C is equal to 0 because it passes through your moment center. So we now have the resultant couple, which is M, and this is going clockwise. Hence, we have negative M. And this is therefore equal to the summation of moment of all the forces in the original force system. So your 80 is going clockwise about point C. So we have minus 80, multiply this one by the moment arm, which is equal to 16 inches. 75 pounds has no moment about point C because it passes through the moment center. Your 90 pounds is going counterclockwise about point C. So we have plus 90, multiply this one by the moment arm, which is equal to 10 inches. It is equal to 10 inches. Hence, minus M is now equal to 380. So this is equal to negative, so this is equal to 380 pounds. Now we have minus 80 by 16 plus 90 by 10 is equal to negative 380. So this is equal to negative 380. So the unit of the force is pounds and the distance is in inches. So this is pound inch, or that is inch pound. Therefore, the moment is equal to 380 inch pounds. And we get a positive value. Therefore, the resultant couple at point C is going clockwise. Okay, so problem number 2. Now, a couple of magnitude M. So we have your couple of magnitude M, which is equal to 540, and that is Newton meter. So we have Newton millimeter. So 540 Newton millimeter. And 3 forces are shown. So we have vertical force at point A. We have 30 newtons at point B, 60 degrees with the x-axis. And we have 45 newtons at point C, that is in the direction of the x-axis. Now, let us try to determine the magnitude of the components of the 30 Newton force. So we have your f of x of the 30 Newton force is equal to 30 cosine of 60 degrees. Again, 60 is included in the x-axis. And your Fy is equal to 30 sine of 60 degrees. Okay, so we now have your Fx and your Fy. So this is now your f of x. And this is now your f of y. So your f of y, and this is now your f of x. Let us try to determine now the resultant or the magnitude of the resultant force. So to determine the magnitude of the resultant force, your Rx is equal to summation of forces along the x-axis. So let us try to consider going to the right forces as positive. So this is fx, and the value of fx in here is equal to 30 cosine of 60 degrees. So your Rx is now equal to, okay, so we have going to the right, so it's positive 30 cosine of 60 degrees. And then minus 45 going to the left. Okay, the 10 kilonewton load has no x component because that is vertical. Hence, your Rx is now equal to negative. So your Rx is negative 30 newtons. Rx, therefore, is equal to, since we get a negative value, therefore, the resultant Rx is now 30 newtons, and that will go to the left. Next is your Ry. So let's try to determine now your Ry is equal to summation of forces along in the direction of y. Let's try to consider upward forces positive. So your Ry in here is now equal to, so we have this going down, so we have minus 10. And this is going up, Fy is going up, and the value of Fy in here is equal to 30 sine of 60 degrees. That is plus Fy, which is equal to 30 sine of 60 degrees. So your Ry is now equal to 15.981. So it's 15.981 newtons with a positive value. Therefore, it goes to, or therefore it is upward. Let's try to determine now the magnitude of the resultant R. So this is equal to the square root of Rx squared, so that is 30 squared, plus Ry squared, we have 15.981. And this is therefore equal to, so the resultant is now equal to 33.991 newtons. 33.991 newtons. So let us try to determine now the angle that the resultant makes with the x-axis. So your theta with the x-axis is now equal to the arctangent of Ry all over Rx. This is equal to 15.981, the arctangent of 15.981 all over 30. And your theta x therefore is now equal to 28.044 degrees. So that is 28 0.044 degrees. Hence, the resultant force, which is equal to 33.991 newtons, is up to the left. So it's up to the left at theta x equal to 28.044 degrees. Okay, so let us try to determine now the intersection of the line of action of the resultant with AB. So we have now with AB. So this is your X, and the resultant force is up to the left. So we now have the resultant force. So I'm just going to consider this is now the resultant force R. So the resultant force R is now making an angle of 28.044 degrees. This is your point A, and this is now your point B. So let us try to determine now the intersection of the resultant, line of action of the resultant with AB referred from point B. So let's try to refer this one from point B. So I'm going to consider that this is now, this distance in here is now, okay, so we have the distance up to this. I'm just going to consider this one as X. So this one is now equal to X. So if that is now equal to X, let us try to determine the value of X. Now, I will going to resolve the component of the resultant at this point. So you try to take note that you can resolve the component of any force along its line of action. So this is your, okay, so we have the resultant R, this is your Ry, and this is now your Rx. Now, so that to determine the location or the intersection of the resultant with line AB, so we now have the moment of the resultant about point B is now equal to the summation of moment of all the forces about the same point B. Your Rx has no moment about point B. So let us try to consider counterclockwise moment as positive. So Rx is going to the left and Ry is going upward. So again, Rx has no moment about point B because it passes through your moment center. So your Ry is going clockwise about point B. So we now have minus Ry, the moment arm is X. And this is therefore equal to the summation of moment of all the forces in the original system about point B. So about point D. So we have 540 Newton millimeter. So this is a counterclockwise moment, and that is positive 540. The moment of the 10 Newton load about point B is counterclockwise, so that is plus 10, and we have the moment arm is 120 millimeter. The moment of the 45 Newton about point B is going clockwise, so we have minus 45, multiply this one by the moment arm, and that one is 80 millimeter. Now, your Ry in here is equal to 15.981 newtons. Multiply this by x is now equal to, so it's negative, and this is equal to negative 1860 Newton millimeter. So, the algebraic sum of 540, 10 by 120, and minus 45 by 80 is minus 1860. And therefore, the value of x is equal to 1860. Divide this one by 15.981. And this is therefore equal to 116.388 millimeter. 388 millimeter. So that is from point B. Next, let us try to determine the intersection of the line of action of the resultant about intersection. So we have now the intersection of the line of action of the resultant with line BC. So we now have your BC. So this is now your AB, and this one in here is now your BC. This is your A, this one in here is now your B, and this one is your C. So we have the resultant. So this is therefore the resultant force. So we now have the resultant R. So this is now, again, let us try to get it from point B, such that I will now going to consider this one as Y. So we have now your Y. So we have the component of the, I will going to resolve the component of the resultant at this point. Or